we're going to overview the different lifecycle methods that have automatically been added to our C++. So the first thing we want to do is open up the C++ if you haven't got it open already. Now, there's a couple of ways of getting to the Visual Studio project. One way is to go to Explorer and open up the solution file there. The other way would be to go to your content browser, and then if you open up the sidebar here using this little icon, you can go to your C++ classes and the blueprint to C++, which is this project, and you can choose to open the C++ files this way directly. So then once that has been loaded up, what we can do is have a look at what we've got in here. There's a slight difference between what's in the Quest Manager and what's in the Grabber. Let's have a look at the header file first of all. So what we've got is a constructor. That should be fairly familiar. We'll talk a little bit about when the constructor is called, however. We've got begin play, which from Blueprints may be familiar, and tick component, which again may be familiar from Blueprint, but we're going to talk about when it is called. Now, if we go over to the quest manager.h, pretty much the similar thing. We've got a constructor, a begin play, which looks exactly the same. However, tick is different. It's tick instead of tick component, and that's just the difference between actors and components. So let's have a look at when these are called by going into the C++ file and putting some log statements in. Logging is a very valuable skill in C++ and in any coding. So the way we do it here is to use the UE_log macro, and then we have to give a category. Now, if you don't have a category set up or just want to be debugging at this moment, then we can just do log temp, which is a pre-set up category for temporary logs. And then we can choose the verbosity. So we are going to go for warning because this makes it just slightly more visible in the log. There's a long list of potential other levels of verbosity. You can find the full list over in log verbosity.h. There's no log, fatal, error, warning, display, log, verbose, very verbose, and so on. Now, we're just going to stick with warning for our debug logs to make them stick out of the log. Next thing, you have to use the text macro, which just makes sure that we're using whatever character type our platform supports. So on Windows, for example, it'll be a wchar, and it just avoids any unnecessary conversions back and forth. And then we can put a log in here. So we're going to write grabber constructor. And as it happens with ulog, you actually don't have to put a semicolon on the end of the line, but I tend to do it anyway, just for good habit. I'm also going to remove this comment line just above. So that's going to tell us when the constructor is being constructed. I'm going to put similarly one in begin play and call it the grabber begin play. And I'm going to put one in tick component as well and call it grabber tick component. Now, I've gone ahead and done the exact same thing over in questmanager.cpp. I've put one in the constructor, begin play, so that we can have an example of all of these things happening, and it should be fairly obvious what the results are going to be. So now I have gone ahead and compiled. We can go over into Unreal, and there's no need to reload the editor. We should just be able to go ahead and hit play and see what's going on in the log. But where is the log? So first of all, we've got to make sure we've got that. I'm going to go to Window, and then we're going to go to the Developer Tools, and we are then going to go and find the output log. And then the output log I'm just having docked next to the content browser. And what we'd expect to see is the warning messages coming up in yellow, so they're nice and obvious. And first of all, we can see right off the bat that our constructors for the grabber and quest manager have already been called, and we haven't even hit play yet. So we can infer from that that constructors are actually called at edit time as well as play time. So if we go ahead and hit play, and then we quickly want to stop because ticking happens every single second, you can see that the ticking and the tick component are being called not every second, but every frame, and they're alternating, which would make sense. The first thing that is called, though, in fact, is the constructor. That's called again when you play a separate instance of the game. And then after the constructor, we are getting begin play, which is happening before the first tick. So that's what those methods are useful for. They allow us to insert something that happens after we're already constructed. Everything is already in the world, but before ticking begins, and then when ticking happens, which is every single frame. The constructor, on the other hand, has to be called in the editor, because if we want to bring up an instance of this thing to be able to add default values and so on, that's all happening over in the constructor. Which leads me to the question of this line here, line 10, primary actor tick can ever tick equals true. And there's an analogous line over in the grabber CPP where we've got the primary component tick can ever tick equals true. Now, this is an efficiency measure. If we set these things to false, then this object is not even going to be considered for ticking and allows us to save some CPU cycles. However, this will be completely overridden if you do use a tick in your blueprint. So just bear that in mind. Just to summarize, what we have seen is how we can use constructors, begin play, and tick component, both in actors and in components, to allow us to hook into different stages of the life cycle of an object.